Oh, I totally didn't mean to turn it off. Oh well. So the first thing that we went over with logs, I thought we understood this. Maybe we just got confused with all the stuff on it, but if you just remember what a log is and how it relates to mainly exponents, not even really roots, you don't have to do roots too. You just remember that piece of it. I mean, that got you 2 or 3 questions on the quiz, or should have gotten you 2 or 3 questions on the quiz. Did it? So if I have a log, I write, log, base, whatever. Actually, let's just use all variables. We'll do that this time. Start really from scratch. And then we'll put some numbers in. All right. So I'll use the same. All right. So if I have a log, I'm going to use all kind of variables. We'll start with that. What does that mean? What's the first thing, base level thing you should be able to, how you would read that? Not log of b is x, but there's something else we said we can kind of convert it into something we're more familiar with, which was exponent. How would I say that using bases and exponents? Yeah, b to some power. So now I'm going to write an a over there. B to some unknown, potentially unknown, and this problem is unknown, power equals that bigger number. We have a log revolve around just understanding that. If you just understand that, probably shouldn't skip this far, but let's do it. So if I said this, and we're going to go over this more today anyway. How would you simplify, evaluate that? Well, how would we read it? We're going to go with Carter on this. How would I read? Again, we'll solve it in a minute, but just what would I even do? If I said b raised to some power is x, what would I say over there? And the a is kind of the answer. That's what, when we say evaluate it, we're trying to figure out what is x. So how would I read that? This right here. That's your Bible right there. That's how you read along, what it means. If you need to write it out in words, I would suggest you write it out in words. Don't ever get that, you'll never move forward. Because even the most well, not even, a lot of the very complex problems still boil down to you just be able to read it correctly. And I'm not saying it's easy, but that's where you practice. We did not practice. Well, I'm still waiting on Carter for this one. So again, match up. What do I have? I mean, it's the same format as I had there before I put the A. Match it up. What is the B over there? No. But what's over there? What is the B over there? It's E. What is E? Like, anybody remember? We did a whole thing on E. What is E? You may not. What's that? It's not 10. Then we would have a 10 there, or nothing at all. There would be 10. What was E? I did a whole lesson on where E came from. We're going to have to bring E back into play in the next chapter. That's what I'm going back in. What's that? This specific letter actually means something. E. It's on your calculator, I bet. Or maybe it doesn't say E. It says something else. It is a very in finance world, it's a very important concept. Yes, e to the x comes from this. Correct. Yeah. So if you look up where it says ln, look up above it. It says e to the x. So what is that E? Why is there a letter E on our calculator?
It says it's 0.
It's not 0. You're probably doing a function with it, but let's don't worry about the E to the X thing. What is E? Not unknown. That's the thing. It's actually not an unknown number.
Pi.
It's kind of like pi. It's a number. Pi is a number, right? Pi 3.14, blah, 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 15, whatever. E is a number. It's a 2.7. 2.7, 1, or the 8, 2, 7, I'm sorry, 7, 8, 1, 8, 1, 8, then it goes on forever. E is a number. That's all E is. So there's a way to do this with numbers, but shouldn't even need to use numbers. So this would be one on the quiz. I would say do it without a calculator, and you'd have to show me how you do it without a calculator. So E is just a number. So now, again, this meant over here. This meant B raised to some power, which eventually I made a variable A. B raised to some power equals X. Right? What's that? Power of some. No, we don't know it. But we don't. That's what we're trying to solve for. So if you want to use a variable, you could use your variable there. So that's what it means. So what's the answer? Hey.
Why is that
I don't know when you say the other one. That because that's what this means. It means E raised to some number, right? That's what we said this means. B raised to some number, which is kind of our answer. That's what we're solving for, equals X. Well, then this means E raised to some number. So originally that was a question mark. E raised to some number, which is why we have a variable, equals E squared. This raised to that equals that. Whatever is here is like that's your big number. Well, I mean, there's no set answer. It depends on the problem, but it can be read as an exponent. So again, this would be the base. Whatever's down here is the base. Whatever is out here, which they might give you this and not this. So again, it depends on what part of the problem they give you. Like I could give you this. Log base 5 of X is what? What's X? Nope. X isn't 2. Read what it means. Again, all comes back to this. If you're not following this, no, I have different missing information. You're trying to follow the same process when I gave you different information. This is 5 raised to that power equals that. This is B raised to that power equals that. Over here, we didn't have that. That's why it was something. This was the X. Again, it depends on what information you're missing. This was the missing. That's why that was the exponent. Over here, that's not missing. So the X is now going to be what we raise it. This is why I shouldn't have skipped it. I thought this was super easy, and clearly it wasn't super easy. This, oh, and you're definitely not, trust me, I just graded quizzes. You're definitely not the only one. Nobody understood logs. I mean, maybe 4 or 5 people passed the logs. This base, so this is the base. I think that's the one that's easy to understand. This is the exponent out here. If it's an X, then X is the exponent. If it's a number, then it's that. And then that all equals whatever is here. So that is the way we would rewrite it. Okay, well, what's 5 squared equal? Well, it equals 25, so X equals 25. Well, baby steps. We'll get to those in a minute. Let's make sure we get this stuff down first. So let me give you actually some of these in your. So now look at the worksheet. There is a worksheet where you have some. Oh, which one is it? Back
None
this
of them.
one.
It's got all the fractions on it.
That's it. For the back page 2. For some of them, I guess. That's the one.
None of this looks so. Yeah, none of this looks like that.
Well, I mean, number 1 is like that. Maybe not. It's a little trickier, but it's not. Maybe I didn't. Here, I'll put the other one up on the board. Maybe that's not one of the ones I made copies for. Let's see. Yeah, here we go. All right, there. So we have. Hold that thought. Yeah, no, I know you don't. Well, again, this I wasn't going to print 100 pages. This stuff we aren't doing this. This is not your quiz. This is what you should already know. Now, we'll practice it some. This is not your quiz. This is like algebra 1, not even algebra 2. No, no. I'm going to zoom in. Oh, let's see how. I think. Yeah, that didn't right. All right, let's just do it the old fashioned. There we go. All right, so what is number 1? You can write these down. Don't sit there and do nothing. Write these down. These are your notes. These are not your problems. These are your background notes. So write it down. Clearly, we didn't write it down the first. Because I did a whole lesson on it. It's not new. I mean, I did a whole lesson on what a log is. If nobody has those notes. Yeah, whenever we first started log, we did a whole lesson, talked about what it means quickly. And you may not know. You should all feel attacked, but you know why? It's not that you're not getting it. What drives me crazy? Well, that I didn't get a single question. I mean, nobody knew what in the blank they were doing. Can't fix that. You say, hey, I don't get it. I can fix it.
I did words it out loud.
You do, so you must not be. These group either are too quiet or don't care enough or asleep or whatever. That's what drives me crazy. Again, if you don't get something, you better not be scared to ask a question. I don't care if your peer, because trust me, I'll tell you right now, none of them got it. So you're not the only one. So ask a question.
I'm not 6.
So yeah, so what would we rewrite this as? Yeah, so this to this power equals that. That helps you remember it. I mean, even the most common, well, not the most common, but almost. I mean, that's what it all boils down to for a lot of those problems. You'll see when we do some of these, you're like, oh, that's no way we're gonna. It's the same thing. It's a little trickier to figure out how to set it up in this kind of format, but this is basically how we're going to set even those complex problems up in order to solve. We're going to try to, can't always do this, but we're going to try to make it into a base and exponent. And let's see if we can figure it out from there. And sometimes we have to have the same base, so we talked about that. Now, sometimes you're going to have to try to figure out a way. Not always, but sometimes that'll allow you, like I can show you really quickly. If I set this up as, like, let's say this was X out here, that was X, well, the way we're really doing it is 6 raised to the X power equals 36, but I could write it like that, same base. So X has to be 2. Sometimes changing this number or some number in there to a base in an exponent, there's again, in the next chapter we do, they use it. Somebody asked me a question. I don't think it was this one. They mention a 1-to-1 exponential relationship or something like that somewhere in the book. Because somebody asked me in seventh period, and there's a lot of that in the next chapter. But what we would love to do in every situation is change it to this, something like that. Change it to where we have the same base. Well, there's no real answer to this because they've given you everything. There's nothing missing. So there's no answer. We're just rewriting it. Like there's, oh, let me have to, that's not, yeah. Hold up. Huh. I don't see my little guy that allows me to erase everything. Interesting. Yeah, that's not it. Nope, nope, nope. How in the world? Well, that's not gonna work. Huh. I wonder if it just doesn't work, and I'm pretty sure I've done it before. All right, let's do this then. Because I would rather have this somewhere where I can easily write. So let me see if this will work real quick. I'll put it over so go ahead and try to do some more of those. Rewrite while I'm setting this up. You don't need to wait on me. Should be able to, this again, this is not, although I did put one of them on the quiz. I actually messed up the one on the quiz. Not really. Yeah, I kind of. Maybe I'll place that over. I think you should still be able to see it okay on here. Yeah, that's fine. All right, so I'll give you a minute, rewrite a few of those, and then we'll check and we'll see how we're doing on it. Don't sit there and do nothing, please. That's gonna be the file screen. Because you're gonna be having another logs quiz. So some of the exact same log stuff you already didn't know how to do. And oh yeah, let's talk about that. You got 2 weeks of grades left, and that's it. So I don't do anything the last week of the quarter. And you got one deadline this Friday. A lot of you have come in and done that one already. I kept extending it. So synthetic division, you can do up until this Friday. Then that linear modeling one, which was not the direct variation thing. You just got it? Good or bad? It's something on it. What was that linear model? That was one where there were a bunch of questions you had to answer about model learning. And you did have to create an equation, and one of them I gave you, I think, a scenario where we had some data. We had to explain what each piece of the equation was. We could not be able to get down on that. Yeah. That's the 3 to the 4th video.
But, oh, so you don't have to do all that?
I mean, there are different ways to write it. But yeah, you don't have to change the base. I would just write it. For now, if you want to practice writing it different ways, that's not going to hurt. So what Marissa was just saying is, she said, well, doesn't that mean 3 to the 4th equals 9 squared? Well, that's fine. I'm going to rewrite it like that because ultimately we'd really like to have it like this. 3 to the 4th equals 3 squared. So 3 to the 4th equals 3 to the 4th. There's a whole bunch of ways you can write it. The more of them you understand, the more you get. Yeah, that means same thing. The better off you will be. We could write it again. I'm saying the more there's not an infinite number, but there are probably 8 different ways you could write that. As long as you understand, they're all the same. Again, there's not just one answer. Is what I'm saying. But what you did was fine. 9 squared I don't think. But the key is this raised to that power equals that. That's where you have to know to start. And again, you'll see when they get more complex how this comes into play. Now that you're easy, you better be able to do this. So with a fraction, I'll just tell you what does that mean? Like what's 1/2? What do we say? So we'd write this, right? Raised to the 1/2. Well, what does that really mean? Yeah, raising something to 1/2 is the square root of it. So if you took the square root of 289 on your calculator, you'd get 17. Or if you squared 17, you'd get 289. Oh. So the half power is just same thing as saying taking the square root of it. You do need to know that. Here's another one you need to know. You need to know what a negative exponent does. Again, the more ways you know how this, there's no wrong answer as long as the value on the left equals the value on the right. We're just rewriting. The more different ways you can rewrite it, the better off you are. Well, let's rewrite it the obvious way. What's the obvious way? 14. And what did we say about a negative in the exponent? Not square root. It's not proper math grammar, we said, right? We don't like, sometimes you have to do it to help you solve, because that does make some solving easier. Say it again. Easier than that even. Like there's not even really math. So sort of flipping it, what do we say you really do? What do you mean by flip it?
You make it not a whole number because you put the numerator in the denominator.
So you make it a fraction.
Yeah.
And 1 is the numerator. So if you have a negative exponent, you just basically move all of this to the denominator and you put a 1 over the top. That's how you get rid of the negative. So that's equal, right? 14 squared would be 196. Well, again, this is the true rule, though. You take the term that has the negative exponent, you move that whole thing to the bottom without the negative, and then you put it underneath the 1. Make it the inverse one. So again, that's just rewriting. There's no real math there, but you need to understand all the different ways. The more different ways you understand how you can rewrite it, changing the base, all that kind of stuff, better off you are. Well, again, depends on the problem. Like there's some of them you can solve without a calculator. Some of them you would have to have a calculator. Like, for example, what was the rule we learned? Here, let me get rid of all of this. Some of it won't go away, but what was the rule we learned? I am going to get rid of this because it's driving me crazy. Yeah, I don't care about that over there as much. So if I just gave you this, what did we say you could do? Because let's say you didn't know what the answer was. How do we say you can evaluate that? So here's your first log rule. This is the one you had to memorize. Well, let's say you didn't do it that way. We know that one, but like let's say it didn't. Trying to get I don't know if you're here for the rule. What was the rule we learned? First log's rule to evaluate in a calculator. No, before that. It was the change of base rule. That's the only one I made you memorize. So the change of base rule said we can't put something into the calculator that has a base of 6. There's no calculator function for that. We have to use a base of 10. That log function on your calculator, it doesn't work off of just any base. You can't just pick any base in the world and use it. It only works off of what base? 10. So we said, okay, well, if I want to use that log function, I have to know this thing called the change of base formula. I'm just going to draw in here. And it says I can use any base that I want. Again, I'm going to pick 10 because that's the only one I can actually put into a calculator. And I can take the log of the big, I don't even know what that's called, but I'm just going to call it big number, divided by the log of the base, and that'll give me the answer. So what I want you to do in your calculator is do that. Take the log of 36 divided by the log of 6. What you get to. Calculator. Now that it's in, so this is base 10 now. If we don't show a number, then that means the base is 10, which is what your calculator uses, a base of 10. It's kind of like an exponent. We don't show that there's an exponent on this 4 of 1. We don't show it. Same way with logs. If you don't see the base shown, then it means you're using 10. So that shouldn't be correct. I think you forgot to close. You got to close the parentheses after you do the log of 36. We know the answer is 2, right? We know 6 raised to the second power is 36. So we know the answer is 2. I'm just showing you how that works. If you ever forget that formula, just take something that you know the answer to, and we already did it, right? So that's how you can kind of work your way backwards into a formula. Say, well, let me just do a log of something that I know the answer to. See how I can work my way back into that correct answer using the calculator. I know it's something about division or multiplication. And then you can figure the formula out if you forget it. It's only one formula, if you remember it. So again, this would be log of 81. And if you want to try, you can. Divided by log of 3. And pretty sure you're going to get 4. So that's how we evaluated in the calculator. That was the change of base formula. That one you need to know. Between, which, isn't a super complex one, but between that formula and between just understanding what a log is, I'll have the other ones the other properties you need, the product, the quotient, the power. I'll have those up on the board. You just need to know how to use those. I mean, this should not have been that. I understand that logic is complex, but it shouldn't have been as bad as it was. I mean, you guys had tons of practice on that.
Were you able to use calculator?
Yeah. Well, no, some of them I said do it without a calculator. So you did have to know how to do some things without a calculator. But yeah, you got to calculate. I mean, I didn't stop you from checking your answer. Like you could have still used the calculator, figured out what you should come up with, and then just try to figure out how to work your way into it. All right, so let's go to the next section. Again, still rewriting. Try to write that as logs. You haven't already.
What?
So you're just doing the opposite of what you just did. Now we're going from this and writing it as a log. Like log, what base equals what number? Adam. Yeah.
Circle.
Yeah, it's a little bit different than you might think on 5. Don't use a square root. I don't want you to do a square root. Try to go backwards. The first one's probably one of the harder ones, actually. Because you want to do it, at least I feel like you're going to want to do it a different way, but that's not writing it a lot. I'll tell you this. It's not it's not log base 8 of 64 equals 2. That is not, I feel like what some of you are going to want to do.
I did it backwards.
Well, I just told you what it was, so you shouldn't have rings.
I never did get
I mean,
simplify it or something?
we can do it if you want to talk about it. I'm not stopping you. Like I'm not trying to keep this big secret. Like you want to compare with people, compare. So again, this is the base. The base is always the base when you change it to log. That doesn't. So log. The log base goes down here, right? So when you say the power, like what goes on the far right?
Oh, wait, no, it's not.
Yeah, that's what I wanted to say. Yes, so eight's not the power. One half would be the power. I don't know what. Yeah, I don't know what to call this. I need to look that up. I call it the big number. Eight's the big number. There's a word for it. Does anybody know the word for it? Probably in the book, I'm sure. I mean, we're saying we are taking the log base 64 of 8. Like we just say of 8. I don't know what the word for it is. So. Yeah, so I don't, that's why I've never. Oh, that's right. Yeah, you don't have a problem. So we would say log base 9 up of 181st equals. Yeah.
Eating.
What?
Good MCA.
Yeah. Oh,
Yeah, you looking for.
be nice that you're told that.
Oh.
So again, I guess we can start filling in. So what is 6? Yeah, the base is always the base. That should be easy. Once you get that part, what's on the right side is the exponent. So that should be pretty easy. Even if it looks weird, the exponent goes on the right. So then the 144 would have to go there. What about down here? So the base is 9, right? Again, base is always the base. And then the exponent's the easy part. It's called the power. And what's that called? Now, I would think of this as the power because that's
the answer. Basis to the power of the what happened. Maybe that's an example of it. But it says that
I would not have guessed that. I mean, I guess because that makes me confused thinking this would be the exponent, which is not. That's the exponent. That's the power. So I would have never guessed that. So I may not use that. This is definitely the answer, though. I mean, that's ultimately what you're getting to right there. The log base 64 of 8 equals 1/2. That's what you would get on your calculator with 0.5. Yeah, I don't know. I don't know. So again, this one's a little trickier over here, but for now, I don't know that there's anything wrong with saying that. That's the base is the base. So if it's the base here, it has to be the base there. We could write 12 to the -1. That would be the same thing. Again, I'm just mostly concerned with you getting that process of which direction it flows down. I'm not so much worried about math, grammar, and what's normal, acceptable. All right. So now they're having you do the same thing just with variables in this 9 through 12. I'm not going to worry about doing that all over again. We've already done it with numbers. Just it's the same thing. U raised to the V power equals 15/16.
Yeah.
Same thing. V raised to the fourth power equals U. They're not asking you to solve for anything, so we don't need to do anything else. That was all of that. So now let's see if there's I think there's a section on this one that's the I'm hoping. Yeah, here we go. All right, so here's some easier ones. Let me cut and paste into the others. And then I'll let you work on these for a little while. If you get bored, if you want to, start doing the other worksheets that I gave you. You're like, this stuff is just way too easy. You might as well start on the other stuff and see how you can do on your own with that. Those are a pretty big jump from this, though, so you know. Some of them. Yeah, why don't, how am I gonna do that? I guess I'll just leave these up for a while. Did they have, are you asking me for the pass? Yeah, no, you just take it. That's fine. All right, so here's the ones where I mean, again, kind of the same thing we just did. So I can probably zoom out a little bit for that. So, one, but copy the problems down. Yeah, there's 5. I kind of can't see the last 2. I mean, none of these are super, super difficult. I didn't print a whole sheet of it. Same thing you just did, only now you're coming up with the answer. Now I didn't give you what would be on the other side of the answer. No, you shouldn't need to.
What?
This means what?
It means 4 to the unknown power equals 64.
You shouldn't need a calculator.
Okay, so, oh,
What is that? So you're basically saw again. This is the one-to-one thing. The one-to-one says I would change that to that base of 4 and an exponent of 3. Now you can see now that it's a one-to-one base. The base is the same. That's what one-to-one kind of means. Now that I've converted it into the same base, it's pretty easy to see what my
okay, so the answer.
Yeah, so 3. When you solve it, evaluate it, simplify it, whatever you want to call it, the answer to this is 3. It equals 3. You plug that in. You could evaluate it like this if you wanted. In a calculator, you could do that. I mean, sometimes you will, not on this one. I mean, you should be able to do it. I think all these you'll be able to do without it. Yeah, none of these should need a calculator. They're all nice round integers for answer. Yeah, they're all nice round integers. You shouldn't need a calculator for anything.
I don't know my powers, so I'm gonna use it for that.
Oh yeah, I'm sorry for that. Yeah, I meant you don't need to take the log of anything. Yeah. I see what you're saying. No, I'm fine with that. Now I see.
Screw.
What I will say. You should be certainly able to square all of the numbers. Yeah, 6. The base is 6. Actually, we can probably scroll down now. You should have all done, or at least written down 22 by now.
Oh.
So there's going to be a negative. Anytime you have a fraction, there will definitely be a negative. Correct. So number 24, be some negative stuff involved. Let me see which, maybe if you're bored, if these are going too slow. Let me see if. What? I mean, I'll tell you right now, this one worksheet isn't nearly as bad as you probably think it is. So if you look at the one that starts out with log of 5x equals log of 2x plus 9, I'll write that up.
Oh, what is that?
It's way easier than you're thinking. Log of 5x equals log of 2x plus 9, right? That's your problem. So if those are equal, what has to be true? Those are the same number. Number on the left will be the same number on the right.
2x. Wait, 2x.
Yeah, that's all you're doing. There's actually 0 logs in it at all. It's algebra.
So,
If this is going to equal this, then this has to be the same number as that. That's all it means. 5x equals 2x plus 9? Seriously? You just said they have to be equal. That's like basic algebra. Basic algebra. So again, that worksheet, there are several of them at least to start off that all you do is that. Just thought.
hey,
The first two are like that.
hey,
Second two are like that.
what?
Third two, not like that.
Okay.
What is number 6? Flying away.
With my eyeballs. Oh, it's a negative. Yeah, go girl.
Go girl. Um,
Eating.
we're trying number 6.
Oh, you can do that.
Oh, actually, it's not.
You have to flip that. Oh, look. It's a fraction, huh?
Which one's it?
27.
No. Oh, the answer. Yeah. Yeah, correct. The exponent would be not the base is not a fraction. I gotta figure out this one. Very good. Like that. Oh wait. Oh. Here's is what that probably means. Hey. Yes, I keep wanting to make it. It's not saying subtract tomorrow. It's saying
Oh, yes, sir.
before last like 6. Well, somehow we have to get rid of it. If we're solving for x, remember that means getting x by itself, which is what I'm trying to figure out how we do more hard. Trying to figure out how we do that one, because these are definitely tricky. First four are super, super. It's amazing how big a jump they take from them. So that's what I'm trying to figure out is how in the world. Because at first I was reading it as subtract 2r, but it's not subtract 2r. It's they're taking the log base 7 of negative 2r. The 0 power would be negative 2r. Oh, I see. How would oh. The other way I'm trying to present it. So 5 actually 2 so I'll show you 6 in a minute on the one. You should also be able to do the sheet that starts with 9 log base 9 of v equals 0. You should also be able to do that. Well, let me show you that one. Everybody look at that sheet really quickly. I'm just going to do the first problem. So it starts with 9 log base 9 of v equals 0. So this is a good one because it comes into play on some other problem. So again, way different than what we just did, right? Like now you guys your eyes are glazed over, you give it up. Rachel's ready for now. See? It's the same exact thing we just did. We have to just think about how we do algebra. If I'm kind of trying to, because the log of v is like one thing. We can't sort of treat it as just a v separately. This is the log base 9 of v is a number, some number. So if I want to find that number, I need to get it all by itself. So what do I need to get rid of? Here, let me help. That is some number. Don't know what it is yet, because I don't know what v is, but that is some number. I need to isolate it. So I need to get rid of the other 9, right? Not the base, but that 9. How do I do that? Divide, right? That's 9 times, anytime there's no math in between it, that's multiplication. So divide by 9, divide by 9, 9 pretty much just goes away. Doesn't affect the right side at all. So now I'm down to, I guess I can just keep writing it. Log base 9 of v, 0. What does that mean? It just went to 0. So we still have 0 on the right, and it got rid of it on this side. So what do I do now? So what's 9 to the 0 power? No, you did not just say that, Jen. That's where they got the 1. 9 to the 0 power equals v. We know that anything to the 0 power is 1, so v is 1. So whenever you have this thing out here, now if there's a number over here, then you would divide and you'd have a different number on the right, so then that would change the problem. But if it's just a 0, you just get rid of it, basically. So now there's some more problems you should be able to do. Now that I've shown you that. Number 6, on the one that I think a lot of you were working on, where it says 2 log base 7 subtract 2r equals 0. It's that you do it like we just did there. Looks like you do some of the other ones like that too. Number 8, you do like that. Number 7, you don't do it like that, but I think you should be able to figure out. Just remember, when you are taking the log of a number, that's like its own number there. That is some number. Log base 9 of v is some number. I just don't know what it is yet. So you just treat it like it's an exponent that you want to get by itself. Get rid of any other numbers that are on that side. So if I would have been let's say instead of 9 there, if I would have said 9 plus that, what would I have done? Yeah, I would have subtracted to get rid of it, right? It's the same math algebra principles you used before to solve. We would say, well, I need to subtract 9 and then subtract 9. So I would have had log base 9 of e, which we could have still solved out for, is negative 9. Oh, that would have been a big number. Actually, I guess technically it would have small. Oh, thank you. Was anybody else waiting? And so I have other log sheets. I wasn't going to print them all out today, but there will be other ones that I'll make